Hi everyone, welcome back to another video. Today we're going to take a look at the grade 11 November 2024 paper 2. Question number 1 is statistics. 1.1, the table below shows the number of tourists who stayed at a hotel in Durban from the 20th to the 31st of December 2023. Question 1.1.1 says calculate the mean of the data. So to calculate the mean, all we have to do, so x bar is the mean, and that's going to equal the sum of all of these values, because those are the number of tourists, and if we add all of that up, we get 1968, and we're going to divide this by the number of days. So that's 1 day, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So over 12 days, and that's equal to 164. Question 1.2, write down the standard deviation of the data. Now, if you have a Casio calculator, then it's pretty straightforward. You use your calculator, you use the stat function on the calculator, and it will give you the standard deviation. The standard deviation is equal to 65,18. Question 1.1.3, calculate the percentage of days on which the number of tourists who stayed at this hotel was within one standard deviation of the mean. So what we need to do here is we need to first figure out what the range is going to be. So it says within one standard deviation, so we're going to say the mean plus the standard deviation, and then we're going to do the mean minus the standard deviation. So the mean is 164 plus 65,18, and that's equal to 229,18. Then we'll do the mean minus the standard deviation, so 164 minus 65,18, that's equal to 98,82. So that's the range that we are going to be looking for. So the range 98,82, and then semicolon 229,18. So we're looking for the number of tourists that are within that range. So we'll go, that's out, 150 is in, 147 is in, 176 is in, 255 is out, 132 is in, 174 is in, 172 is in, 197 is in, 172 is in, 39 is out. So the number here we have 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 days lie within this range. So 8 days, so the percentage is going to be 8 days divided by the total number of days, which is 12. So 8 over 12 times 100. And that's equal to 66,67%. Now let's take a look at question 1.2. The number of tourists who stayed at this hotel during the entire month of October and the entire month of November are summarized. So in the box and whisker diagrams below. So question 1.2.1, calculate the range of the number of tourists who stayed at the hotel during November. So this is going to be the maximum value, and this is going to be the minimum value. So range is equal to the maximum, so 220, minus the minimum, so 26, and that's going to give us an answer of 194. So 194 tourists is the range. Then 1.2.2, comment on the skewness of the data for October. So we can see here that for October, the right half of the box is larger than the left half of the box. So that means that it is positively skewed. Positively skewed. or you could say it is skewed right. Question 1.2.3. The maximum for October was incorrectly calculated or recorded. The correct value is higher than the recorded value. So that's wrong. Maybe it's 200. If this correction is made, what effect will this have on the mean? So remember, when you calculate the mean, you take all of the values and you add them up and you divide. So if you are adding a larger number, then the mean will change, right? The mean will increase. The mean increases. Then B, how does it affect the median? Remember, the median is just the middle number. If all the numbers are staying the same and we're only changing the maximum at the end, it's not changing the middle number. We are simply doing a replacement. So the median will stay the same. The median remains the same. Question 1.2.4. There was only one day during November on which 64 tourists stayed at the hotel. On how many days during November did less than 64 tourists stay at the hotel? So 64 is my Q1 value. That is also known as the 25th percentile. So if there are 30 days in November, then 25 over 100, so 25% of the 30, will give me the number of days that lie between this point and this point. And that's equal to 7.5 days. And then we will simply just round down because we don't really count half days. So there were 7 days in which there were less than 64 tourists staying at the hotel. Now let's move on to question number 2. The marks in percentage obtained by grade 11 learners in their math exam is shown in the histogram. Histogram showing marks obtained. Okay. So question 2.1, use the above histogram to complete the partially completed frequency and cumulative frequency columns of the table provided in the answer book. So unfortunately, I don't have access to the answer book, and so I don't have the partially completed frequency and cumulative frequency table. However, I've just placed the answer there, and we can use that to then answer question 2.2. Draw the cumulative frequency graph ogive of this data in the grid provided. So we have to use the table in order to get coordinates. So the coordinates are going to be as follows. So we start at 0, 0. That's our first coordinate. Then the next coordinate will be 3, so cumulative frequency is 3, and then the y value, the x value then will be 10. So the coordinate here is going to be 10 and 3. The next coordinate is going to be 20 and 8. The next coordinate will be 30 and 10. Next one, 40 and 19. Then 50 and 37. Then 60 and then 65. 70, 95, 80, 107, 90, 118, and 100 and 120. So we'll start here. So that's the first point. Then 10 and 3. So 10 and 3 is here. Then 20 and 8. I'm going to estimate here. So roughly there. Then 30 and 10. Roughly there. 40 and 19, probably around there. 50 and 37, 50 and 37, let's say around there. 60 and 65, so 60 and 65, probably around here. 70 and 95, so 70 and then 95, probably around here. Then 70, then 80 and 107, so 80, 107 around here. 90, 118, so 90, 118 is around there. And then 100 and 120. And so then this is going to be our course, I've taken some liberties here, but that's the general idea. Now, question 2.3, use the ogive curve to estimate the number of learners who scored more than 75% in the exam. So we're looking for 75%, and now we need to extrapolate. So if I bring this up, so we bring this up somewhere there, touches the graph, and then we got to bring it across. So that's going to be somewhere here. So I'm going to go with roughly 102. So 102 learners, right? So there's 102 learners, and then we are looking for how many scored more than 75%. So there are 120 in total, and then 102 scored between 0 and 75. That means the difference here is going to be 18 learners who scored between here and here. That's 18 learners. Then question 2.3.2, the median mark. So in order to calculate the median mark, we're looking for halfway through the 120 learners. So halfway is 60. So 60 is here. So I bring this across, trying to draw this as close as I can, as accurate as possible. And you bring this down. So it's about 60. So I'm gonna put an estimate here. I'll say that the median mark, of course, when you do this, you will have grid lines and so on to make it a bit easier. So this is going to say, I'll say it's between 58 to 60. So let's go with the middle. Let's go with 59. Okay. So thereabout. I mean, I'm going to put an asterisk here because it's a rough estimate. Okay, let's move on to question number 3.1. P, Q, and R are 3 points on the Cartesian plane. Calculate the values of y such that P, Q, and R are collinear. So if they are collinear, it means that they lie on the same line. And if they lie on the same line, it means that the gradient is going to be the same. So we can calculate the gradient of PQ. So 3.1.1, the gradient of PQ is going to equal the gradient of, you can say PR or QR, doesn't really make a difference here. Let's use QR. So PQ, I'm going to go with 5 minus 1 divided by 2 minus 1, so 2 plus 1. And that's going to equal the gradient of QR. QR will be y minus 5, and that's over 5 minus 2. So this is equal to 4 over 3, and that's equal to y minus 5 over 3. Now we can cross multiply here. So 4 multiplied by 3 over 3 is equal to y minus 5. The 3's can cancel. Y is equal to 4 plus 5, which is equal to 9. Let's take a look at 3.1.2. So calculate the value of y such that PQR is 90 degrees. So if PQR is 90 degrees, it means that the gradient of PQ multiplied by the gradient of QR is going to equal minus 1. So the gradient of PQ we've already worked out as 4 over 3, and then multiplied by the gradient of QR. So QR has a gradient of y minus 5 over 3, and that's equal to minus 1. Now we do need to simplify here. So in order to simplify, we'll say 4 into y minus 5 over 9 is equal to negative 1. So 4 into y minus 5 is equal to negative 9. That means y minus 5 is equal to negative 9 over 4. That means y is equal to negative 9 over 4 plus 5, which is equal to, and I believe this is negative 9 over 4 plus 5, that's 11 over 4. Now, of course, question 3.2 in the sketch below, R, S, and T are the vertices of triangle RST. R, S, and ST intersect the x-axis at F and D respectively. E is the y-intercept. The equation of RS is that, and RST is beta, alpha, and theta, the angles of inclination of RS and ST respectively. Question 3.2.1, calculate the length of RT. This is simply a distance formula. So RT is going to equal the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And we just need to substitute in here. So RT, I'm going to substitute minus 3 minus 1 all squared plus 1 minus 5 all squared, and that gives us the square root of 40. Question 3.2.2, calculate the gradient of ST. So ST, so gradient of ST is equal to y2 minus y1, so 2 minus 3 divided by x2 minus x1. That's equal to 5 over 3. Question 3.2.3, calculate the coordinates of M, the midpoint of RS. So midpoint of RS, so M, that's going to be the sum of the x values and then divided by 2. So 4 minus 5 over 2 and 2 minus 1 over 2. So M is minus a half and a half. Question 3.2.4, determine the equation of a line parallel to ST passing through M. So y is equal to mx plus c. Since it has since it's parallel to ST, it's going to have the gradient of ST. So 5 over 3 x plus c, that's equal to y. And it passes through M, so M is a coordinate that we can substitute in. So half is equal to 5 over 3 into minus a half plus c. Half is equal to minus 5 over 6 plus c. C is equal to 4 over 3. So the equation is going to be y is equal to 5 over 3x plus 4 over 3. Question 3.2.5, determine the coordinates of G if R, G, S, T in that order is a parallelogram. Okay, so R, G, S, T, that means G must be somewhere here, because that's going to be our parallelogram. It's not drawn to scale, it's not drawn entirely accurately, but that's the idea. Now to figure out the coordinates, we can use translation. So the distance from here to here, so this horizontal distance, will be the same horizontal distance from here to here. So from R to T, the horizontal distance is minus 5 to 1, that's 6 units. That means from S to G must also be 6 units. So 4 minus 6 is minus 2. So G will have an x-coordinate of minus 2. Let's look at R and T. The vertical distance there is from minus 1 to minus 3. That's 2 units. That means from G to S is also going to be 2 units. So G is going to be 2 plus 2, which is 4. So the coordinates for G are going to be minus 2 and 4. Now let's take a look at the next question, 3.2.6. Determine the size of beta. So let me just clear this up here. So they want to know what is beta. Beta is this angle there. So focusing on this triangle here, this one, I can work out theta because I know the gradient of ST. I can work out alpha because I can work out the gradient of SR. And then beta can be solved by using exterior angle of a triangle equals sum of interior opposite. So to work out theta, I can say tan theta is equal to the gradient of ST. So tan theta is equal to the gradient of ST is 5 over 3. So theta is equal to tan shift tan 5 over 3, which is equal to 59,04 degrees. Then I can work out the gradient of SR. To work out the gradient of SR, I will say y2 minus y1, so 2 minus minus 1 divided by 4 minus minus 5. And that's equal to 3 over 9, which is 1 over 3. Then to work out alpha, I can say tan of alpha is equal to the gradient of SR, which is 1 over 3. That means alpha is equal to arctan 1 over 3, which is equal to 18,43. Then to work out beta, I can say that theta is equal to alpha plus beta, and that's because exterior angle of a triangle is equal to sum of interior opposite. So 59,04 is equal to 18,43 plus beta. Beta is equal to 40,61 degrees. Okay, question 3.2.7 says calculate the area of SEOD. So SEOD is this shape right here. And in order to figure that out, we do need to first calculate some coordinates. And the coordinates that we're interested in are going to be the coordinate for E and the coordinate for D. So let's start with E. We've been given the equation of RS. So RS is given as 3y minus x minus 2 equals 0. That means 3y is equal to x plus 2. Y is equal to 1 over 3x plus 2 over 3. Now, E is the y-intercept, and so the coordinate for E is going to be 0 and 2 over 3. And now to figure out the coordinate for D, we know the gradient of ST because we calculated it in question 3.2.2. So y is equal to mx plus c. Y is equal to, the gradient of ST was 5 over 3. So 5 over 3x plus c. Now we substitute a coordinate. We can substitute the coordinate for s. So the y value for s is 2. That's equal to 5 over 3 multiplied by 4 plus c. And then when we solve for c, c is going to equal minus 14 over 3. That means the equation is going to be y is equal to 5 over 3x minus 14 over 3. Now to calculate the coordinate for D, D is an x-intercept, so you make y equal to 0. So 0, so D 0 is equal to 5 over 3 x minus 14 over 3. That means 14 over 3 is equal to 5 over 3x. You can then solve for x. X is going to equal 14 over 5. That means the coordinate for D is going to be 14 over 5 and 0. So I'm just going to input these on our graph so that it makes it a bit easier. So this is going to be 2/3, so 2 over 3. This is going to be 14 over 5. And this is going to now help us to work out the area of SEOD, because if I work out the area of this triangle, so this triangle right here, perhaps I should have used a different color. Let's go with this. So if I work out the area of this triangle right here, and I subtract the area of this white triangle, I'm going to get the area of the pink shaded area, which is the area of SEOD. So let's start by calculating the area of this triangle that's highlighted in this purple color. So area 1, let's call that 1. That's going to equal half base multiplied by height. Now the base is going to be from here to here. So this coordinate is -2. This coordinate is 14/5. So the length from here to here is going to be 14/5 plus 2. So the base, so half, the base is going to be 14/5 plus 2. And the height of this triangle is simply going to be the height here. So the height, we're looking at the y value, the height is 2. So multiplied by 2. And that's going to give us an area of 0.5, so 14/5 plus 2, that's equal to 24/5. So the area is 24/5 units squared. So that's the big purple triangle. Then area 2, which is the white triangle, this one here, that's going to be half base times height. Now the base in this case is simply going to be from here to here, which is 2, and the height is going to be 2/3. And so the area of this white triangle is simply going to be 2/3 units squared. So the area for SEOD is going to be 24/5 minus 2/3. So minus 2/3 from this, and we get 4,13 units squared. Now let's move on to question number 4, which is trigonometry. If 2 cos beta plus 1 is equal to 0 and sine beta is negative, determine without the use of a calculator and with the aid of a diagram the value of sine beta. So let's start with this. Let's start with the diagram. So I'm going to draw in my Cartesian plane. I'm going to write in CAST. So this is telling me what trig ratio is positive in which quadrant. And now let's solve for cos beta. So 2 cos beta is equal to minus 1. That means cos beta is equal to minus a half. So cos is negative in this quadrant and this quadrant. And they further tell us that sine beta is negative. So sine beta is negative, or sine is negative in this quadrant and in this quadrant. So the only quadrant that has both ticks is this one. So that means the triangle is going to go in that quadrant. So let's draw in that triangle. So here we are going to have our triangle. So you drop a perpendicular and join it to the origin. That's going to be 90 degrees. This is going to be the beta value here. Now they tell us that cos beta is minus a half, which means that this is going to be the adjacent side and that's going to be the hypotenuse. Now the hypotenuse can never be negative, so that means this is simply going to be 2. That means the adjacent, this must be -1. Now we can calculate this value. We can use Pythagoras. So the way I do it is I look at the triangle without the negative values. So if that's going to be 1, that's going to be 2. That means this side here, let's call it side O. Let's call it P. So we'll say that p squared plus 1 is equal to 2 squared, or 1 squared. That means p squared is equal to 4 minus 1. P is therefore equal to the square root of 3. So this is going to be the square root of 3. Now, bringing it back to our Cartesian plane here, because these are negative y values, this length here must be negative. So it's going to be negative square root of 3. Now let's solve question 1. 4.1.1, solve for sine beta. Sine beta is opposite over hypotenuse, opposite the beta. So sine beta is going to equal minus square root 3 divided by 2. Question 4.1.2, 2 tan squared beta minus cos squared beta. Now it's just a matter of substituting. So 2 multiplied by tan squared beta. So let's first figure out what tan beta is. Tan beta is going to be opposite over adjacent. So opposite is going to be minus square root 3 divided by the adjacent, which is minus 1, and that is being squared. Then we're subtracting cos squared beta. Cos beta we know is minus a half. So minus a half, and that's all squared because it's cos squared beta. Now we can't use a calculator here, so we're going to have to simplify. So this is going to be 2 multiplied by, the negative and the negative would cancel. Square root 3 over 1 is square root 3, and then square root 3 squared is simply going to be 3. So 2 times 3 minus. Now negative a half all squared is going to give me positive a quarter, because negative a half times negative a half is equal to positive 1 over 4. So this is going to be minus 1 over 4. So this is going to be 6 minus a quarter, which is equal to 5,75, 5 and 3/4. Moving on now to question 4.2. Question 4.2 says simplify cos of theta minus 90 multiplied by cos of minus theta times tan of 360 minus theta over sine of 180 plus theta to a single trigonometric ratio or single trigonometric term. Okay, so cos of theta minus 90. Now because there is a 90 here, it gives me a clue that I need to change it to its co-function. So in other words, cos becomes sine, and if it was sine, it would change to cos. So cos of theta minus 90 simplifies as sine theta. Actually, we can go through it a bit more in detail. One way of thinking about it is, if I have a Cartesian plane like so, and I have some angle here, say that angle is theta, and I am subtracting 90, that tells me I am going in a clockwise direction 90 degrees. So I'm moving it this way. So that's going to be 90, I'm moving it this way. So that means I'm ending up in this quadrant where cos is positive. So I'm going to have positive, and then because cos changes to sine, the co-function, it's going to be positive sine theta. Then cos of negative theta, same thing. If I have a Cartesian plane like this, and I have, and if I'm rotating by some negative angle here, some negative theta, I'm going to have cos being positive here. So that's going to simply be multiplied by cos theta, and then multiplied by tan of 360 minus theta. So again, we can view that on a Cartesian plane. if that's 0 or 360, and I am subtracting theta, I'm coming back by some value, some theta value. This is only where cos is positive, so tan will be negative. So I'm going to be multiplying by minus tan theta. And then that's going to be divided by sine of 180 plus theta. So again, if I draw in my Cartesian plane, if that's 180, and I'm adding in some theta value, CAST, only tan is positive here, so I'm going to be dividing by minus sine theta. Now we can simplify a bit more here. So we can break up the tan theta here. So first let's divide. We can divide this, and we can divide the negative and the negative. Because it's all multiplication, we are allowed to cancel. So we have cos theta multiplied by sine theta over cos theta. So this will cancel with this, and so my answer is sine theta. Moving on to question 4.3. Without using a calculator, calculate the value of 2 sine 510 minus cos of 340 times cos of 20, and then that's all divided by cos squared 110 degrees. So let's begin. So 2 sine 510. So because this angle is greater than 360, we can subtract 360. So if I have to go and subtract, I would write here, let's write it on the side, 540 minus 360. So that's going to give me 540 minus 360. I'm using a calculator here, that's going to be 180. Right? So this is simply going to be 2 sine of 180. Oh, it's 510. My apologies, I need to fix that. So this is going to be 510 minus 360. So 510 minus 360, that's 150. So this is 150 degrees. So 2 sine 150 degrees. And then minus cos of 340. So we can rewrite 340. So remember, 360 minus 340, that's equal to 20 degrees. So we can write here cos, so minus cos of 20 degrees. And it's going to be positive because remember that cos of 340 is the same as saying cos of 360 minus 20. That's the same as saying 360 minus theta. And cos is positive in that fourth quadrant, and so we're not going to then change that negative sign. Okay? Now moving on to cos of 20, so we're multiplying here by cos of 20. And that's all going to be divided now. Let me just clear some space. So that's going to be divided by sine of, no, it's going to be divided by cos of 110 degrees. So cos squared 110 degrees. Now let's work on the sine of 150. So sine of 150 can be rewritten as the following. We can write that sine of 150 is equal to sine of 180 minus 30. Now 180 minus 30 follows the pattern 180 minus theta, and sine of 180 minus theta is sine theta, or sine 30 in this case. So I can write here 2 multiplied by sine 30. Now let's deal with the cos 20. So the cos 20 and the cos 20 will multiply, and I will get minus cos squared 20 degrees. And now let's work on the 110. So cos of 110, the only thing we can rewrite it as is going to be 180 minus. So let's work on that. We're going to have cos of 110, and that's going to equal cos of 180 minus 70 degrees. Now that's going to equal, now cos of 180 minus, that's going to be second quadrant, cos is negative, so this is going to be minus cos of 70 degrees. However, because it is squared, remember squared values, when negative values are squared, they become positive. So when we're squaring this, it's going to make it positive. So you're going to have negative cos 70, and that's going to be squared. So simplified now. So 2 sine 30, sine 30 is a half, so 2 multiplied by a half minus cos squared 20, we don't know what that is, divided by, this is going to be cos squared 70, right? The negative will become positive now. And so now we have 2 times a half, which is 1, minus cos squared 20 divided by. Now, we need to simplify this as much as possible. So the cos squared 70, on its own we can't simplify, right? But we can use co-functions. And cos squared 70 can be rewritten as sine squared 20. Now the reason why I'm doing this is because I can kind of see that I have cos squared in my numerator, and 1 minus cos squared simplifies to sine squared. So 1 minus cos squared 20 simplifies to sine squared 20, and that's divided by another sine squared 20, and that's going to equal 1. So all of that simplifies to 1. Moving on now to question 4.4. Given the following expression, sin x over 1 plus cos x over sin x, prove that sin x over 1 plus cos x over sin x is equal to 1 over sin x. Now, when you are given a question like this, you need to start with the more complicated side. And the more complicated side is going to be the left-hand side. So the left-hand side is these fractions. So we're going to need to get a lowest common denominator. So the lowest common denominator is going to be the product of those denominators. So I'm going to have 1 plus cos x multiplied by sin x. Now for the first fraction, I need to multiply the numerator by sin x as well. So sin x multiplied by sin x, then plus. Then for the second fraction, for the second numerator, I have the cos x, but I need to multiply that by the 1 plus cos x. Now let's expand. So I'm going to have sine squared x plus cos x times 1 is cos x, and then cos x times cos x is cos squared x, and that's divided by 1 plus cos x and sine x. Now the reason why I'm not expanding that is because I'm hoping that something is going to cancel. Now the sine squared x and the cos squared x plus cos squared x will give me 1. So 1 plus cos x and divided by 1 plus cos x multiplied by sine x. Now I can cancel this entire numerator with this denominator, and so I'm going to be left with 1 over sine x, which is my right hand side. Now question 4.4.2, determine the general solution for which the identity in question 4.4.1 is undefined. So since we've proven this, right? We've proven that identity. We've proven this entire thing here. For it to be undefined, we need the denominators to equal 0. Okay? So for 4.4.2, for undefined, you set the denominators equal to 0. So we're going to have two different sets of calculations. The first calculation, we're going to have 1 plus cos x equals 0. That means cos x is equal to negative 1. That means x is going to equal our cos of negative 1, which is 180 degrees. So 180 degrees, and now because we've now solved for the angle, we need to put plus k 360, not forgetting the k must be an element of z. And now for the second solution, we look at the other denominator, which is sine x. We'll set sine x is equal to 0. That means x is going to equal, now remember, for a sine x graph, the sine x graph starts like this, goes like that. We have two solutions here. We have a solution that is 0 degrees, and we also have another solution here which is 180 degrees. We don't include the 360 because we're adding 360 to the k value. So it's k 360, so we don't need to write that one. So here we're going to have 0 plus k 360, and k is an element of z. Or the other solution is going to be x is equal to 180 plus k 360, and k is an element of z. Now for those of you who prefer a more elegant solution, you will notice that every half cycle is 180 degrees, and every half cycle you are going to get a value of 0. So you could just say, or x is going to equal 0 plus k 180, and k is going to be an element of z. Now let's take a look at question number 5. The graph of f of x is equal to 2 cos x plus p. So there's been a horizontal shift, and it's sketched below, and they've given us the domain. Question 5.1 reads, write down the amplitude of f. So to calculate the amplitude, we can say that amplitude is equal to the maximum value minus the minimum value divided by 2. The maximum value is 2, the minimum value is minus 2 divided by 2, and that gives me 2. Or you could just simply read it from there. Question 5.2, write down the value of p. So one way of solving this is by thinking about where a cost graph normally starts. So a cost graph normally starts here. The maximum is here, and then it gets smaller, and that would be the general shape. But in this example, it's been moved. So the maximum is no longer here, it's now been moved this way. Right? It's now been moved to the left. Right? And so it's been shifted by 45 degrees. So the value of p is going to be 45 degrees. And now the reason why I'm not putting negative 45 degrees is because if it's being shifted to the right, that's when we put negative. If it's being shifted to the left, we keep it as positive. Question 5.3. Given that g of x is equal to sine of 2x plus 1, write down the period of g. Okay, so to calculate the period, all we need to look at is the number that is being multiplied by x. So to calculate the new period, simply, we'll take the period of a normal sine graph, which is 360, and you'll divide it by that value that is being multiplied by x, so multiplied by 2. So 360 divided by 2, and that's going to give me a period of 180. Question 5.4, okay, it asks us to sketch the graph. Okay, so here it's just a matter of using the table function on your calculator. So you'll go to mode and then table, and your calculator will give you the coordinates. And so when we plot this graph, it's going to look something like this. So you're going to have a minimum here, you'll have a value here, and then here, and one here, and then here. So I'll use a different color. Let's go with the red. The graph looks something like that. Don't know why it's erased the whole thing, but try again. So something like that. Okay, so that's been done. Question 5.5, use your graphs to write down the values of x for which g of x multiplied by f of x is going to give me a negative value. So in order to get a negative value through multiplication, we need either f of x or g of x to be positive and negative, or vice versa. Now, because we've plotted g of x and g of x has no negative value, that means we are looking for where f of x is negative and where g of x is going to be positive. That's where we are going to have a negative product. So we can see quite clearly here that g of x is positive everywhere here. Positive, positive, positive. It's never going to be negative. So what we're looking for is where f of x is negative. And f of x is negative from this point onward here. So that's going to be what we are looking for. So we are simply going to say that x must be between 45 degrees and 135 degrees. But remember, it cannot equal 135. 180 here. It's 180. Apologies. So x must be between 45 and 180, but x cannot equal 135. And the reason why it can't equal 135 is because the g of x graph is equal to 0 at that point, and the question is not specifying that the product can equal 0. The product must be less than 0. Okay, so anywhere in this region here, that's where we're interested in, and of course it cannot equal that 135 value. Moving on now to question 5.5.2. 5.5.2, f of x is equal to minus g of x plus 2. Now, there's a few ways you can solve this question, but what I've done essentially is I've said f of x, and I've taken the minus g of x across. So plus g of x is equal to 2. So essentially what I'm looking for is where there's going to be a sum. So where's the sum of the y values for these graphs going to give me a value of 2? And if I look at this, I can see, okay, at this point, that's 0 and that's 2. So 0 plus 2 is 2. So definitely one x value is going to be x must equal negative 45. Then if I continue, I can see, okay, here I have 45, that's 0 and that's 2. So x should also equal 45 degrees. Now, I can't put this value because this value has negative 2, and I don't want the sum to equal negative 2. I need the sum to equal positive 2, so I will ignore the 135. Question 5.6 says, graph H is obtained when f is translated 45 degrees to the left. Determine the equation of H write your answer in its simplest form. So the equation of f is going to be, so f of x, let's write the correct thing now. It's going to be 2 cos, and then here it's going to be x plus 45. Now, the graph of h, so h of x, is going to be 2 cos x plus 45, and because we are translating it further to the left, 45 degrees, we're going to add a further 45. So h of x is going to equal 2 cos of x plus 90 degrees. Because I'm seeing the 90, I'm thinking of co-functions here. So h of x is going to equal x plus 90 simply changes to minus sine. So this is going to be minus 2 sine x. Okay, now let's move on to question number 6. Question number 6, a cableway connects the top of two mountains across a valley. The distance from E to F is D. From F, the angle of depression to E is alpha, and the angle of depression to G at the bottom of the valley is beta. The angle of depression from E to G is theta. H is a point that is directly below F and in the same horizontal plane as G. The distance G to H is x. Question 6.1 reads, write down the size of FGE in terms of theta and beta. So we are looking for FGE, which is going to be this angle here. Okay, so this dotted line here and this dotted line here are parallel, which means that this angle is going to be alpha. So I've got a triangle now that looks something like this. So like that, this angle is going to be alpha plus theta. This angle is beta minus alpha, because remember, if that whole thing is beta and that's alpha, then this angle is going to be beta minus alpha, and they want to know what is this angle going to be. Well, we know angles in a triangle are going to be equal to 180 degrees. So alpha plus theta plus beta minus alpha plus FGE is equal to 180 degrees. That means that would cancel with that. That means that theta plus beta plus FGE is equal to 180 degrees. It means then that FGE is equal to 180 degrees minus theta minus beta. So let's write that in, 180 minus theta minus beta. And this is equal to beta minus alpha. Next question says, show that FH, so this height, let's use a different color, let's go with this. So FH is equal to that crazy expression, and it looks a bit difficult, but if we break it up and we make our way from this triangle to this triangle, you'll see how it fits all together. So I'm going to start with the purple triangle, and I'm going to use the sine rule. So I want FG, and that's because FG is a common side to both triangles. So I'm going to simply say that FG over sine of the angle across it, so sine of alpha plus beta, and alpha plus theta, apologies, is equal to, and I know this length, so I'm going to say D over sine of the angle across it, so sine of, now I need to be careful about how I write this, because it's 180 minus, I can apply reduction here, but I need to rewrite this n part a little differently. So instead of writing 180 minus theta minus beta, I'm going to write it as 180 minus theta plus beta. So I'm going to have here 180 minus theta plus beta. And that's because when I'm applying that reduction, sine of 180 simply becomes positive sine of that. So Fg is equal to d multiplied by sine of alpha plus theta divided by, and this will reduce, this is the same as sine of 180 minus some angle, that reduces to sine of that angle, so sine of theta plus beta. Now notice we've already gotten the numerator now, and we've gotten the denominator, and now we can apply, this is triangle 2, we can apply Pythagoras to calculate the value for FH. So we can say that FH squared is going to equal FG squared, so FG squared minus x squared. So FH squared is going to equal FG squared, so that's going to be d multiplied by sine of alpha plus theta all over sine of alpha plus beta, and this entire thing is going to be squared, and then minus x squared. So that means FH is simply going to be the square root of that whole mess. So d times sine alpha plus theta over sine of theta plus beta, and that's all squared minus x squared. Okay, now let's move on to question number 7. So the diagram below shows a sketch of an oil container which is made up of a cylinder and a cone. The cylinder and the cone have the same radius. The height h of the cylinder is 15 centimeters and the slant height s of the cone is 10 centimeters. The volume of the cylinder is 4,000 centimeters cubed. 7.1 for 7 marks. Calculate the total volume of the container. So I'm going to write out the information that I know first. So the volume of the cylinder, so to calculate the volume, so we're going to add up. So the volume of the cylinder, so volume is equal to 4,000 centimeters cubed. And this is the volume of the cylinder. So the formula to calculate the volume of a cylinder is equal to pi r squared h. They've kindly given us that formula. Now, we don't, well, we know the height of the cylinder. The height is given as 15. So we can substitute. We can say 4,000 is equal to pi. I don't actually know the radius, so leave it as r squared. And the height is 15. That means I can solve for r. So 4,000 divided by 15 pi. And if I square root that, I'm going to get r. So r is then equal to 9,21 centimeters. So I've got the radius. Okay, we're probably going to need it somewhere. Let's see. Now we can then work out the volume of this cone, right? So to calculate the volume of the cone is going to equal 1/3 the area of the base. So the base is a circle, so it's going to be pi r squared. So pi r squared, so that's the area of the base, times the height. Now that's going to be 1/3 pi, the radius is 9,21, we're squaring that, and that's going to be multiplied by the height. Now we don't actually know the height, we've been given the slant height. So if I look at the triangle, I know that this is 9,21. I know the slant height is 10. And so if I want the height, I can use Pythagoras. So h is going to equal the square root of 10 squared minus 9,21 all squared. And so h is going to equal 3,89. So multiply by 3,89. And that's going to give me a volume of 345,61 centimeters cubed. And so if I want to work out the total volume now, the total volume is going to equal the 4,000 plus the 345,61, which is 4,345,61 centimeters cubed. Question 7.2, calculate the total surface area of this oil container. So to calculate the surface area, we've got this and we've got this formula as well. So all we need to do here is we need to combine them and just add. So the total surface area here is going to equal pi r squared plus 2 pi rh plus pi rs. So pi, the radius was 9,21, so 9,21 all squared plus 2 pi 9,21. The height of the cylinder was given to us as 15, and then plus pi 9,21, the slant height was 10. And that's going to give us an answer of 1423,43 centimeters squared, because this is area. Okay, now moving on to question number 8. In the diagram below, O is the center of the circle passing through K, L, and M. J is the midpoint of chord KL, chord KM produced, and JO produced meet in N. JN intersects chord ML in H. MO and LO are drawn. K is equal to 50 degrees. Okay. Calculate, giving reasons, the size of angle MOL. So MOL is this. So that's going to be simple. MOL is going to equal 100 degrees. Because that's the angle at the center, and angle at the center is twice the angle at the circumference. Next, calculate angle L1. So angle L1 is this angle here. So because OM and OL are radii, it means that triangle MOL is going to be an isosceles triangle. It means that M2 is going to equal L1. So we've got, let's call this X and let's call that X. We're going to have 100 plus 2X equal 180. That means 2X is equal to 180 minus 100. That means X is equal to 80 divided by 2, which is 40 degrees. So this is going to be 40 degrees, and that is also going to be 40 degrees. Now they want us to calculate angle N. So in order to calculate angle N, we need to look at the information that we've been given here. We've been given that KJ is equal to JL. And that means that J1, this here is going to be 90 degrees. And that's because OJ is a line drawn from the center. And that line that's drawn from the center is actually bisecting that chord. And so because it is bisecting the chord, it means that J1 and J2 are going to be 90 degrees. So now we can simply focus on this triangle right here. We know that this is 50 degrees. We know that that is 90. And so N must be the remaining angle. We can use some angles in a triangle. So n is equal to 180 minus 50 minus 90, which is equal to 40 degrees.
Let's take a look at this Euclidean geometry question. We've been given a diagram with some information, and they've given us some questions. Question reads, calculate, giving reasons, the size of MOL. Now MOL is this angle right here. That is an angle at the center, and so we should be looking for angle at the center theorem. We know that the angle at the center of a circle is equal to 2 times the angle at the circumference. So the angle at the circumference was given to us as 50 degrees, which means that the angle at the center will be 100 degrees. Next, they want us to calculate L1. L1 is this angle right here. It falls within this triangle right here, which is going to be an isosceles triangle, because since O is the center, OM and OL are equal since they are radii. So we can solve for L1. So L1 is going to be 40 degrees. M2 will also be 40 degrees, and we can verify this because if we add all the angles up, we get 180. Last question is to calculate angle N. Now to calculate angle N, since angle N lies outside of my circle, I can't really use any circle theorems. However, angle N falls within a triangle, this triangle right here. Now if we can figure out the angles in that triangle, then we can work out angle N. Now I see chord KL drawn for me, and I can see that KJ is equal to JL. This brings me back to a theorem where if you have a line drawn from the center, and if it bisects a chord, it means that it's going to be perpendicular to the chord. So now we have 2 angles, and we can figure out the third angle, being angle N. So this is my triangle right here. We have an angle 50 degrees. We have an angle 90 degrees. That means we can solve for this angle, which is going to be 40 degrees. Let's take a look at this next question, which reads, in the diagram below, O is the center of the circle, P, S, R, and K are points on the circle, SOK is a straight line intersecting PR at T, PS equals SR, and OR is joined. S1 equals X. The question reads, calculate P in terms of X. So to solve this, I'm going to start by drawing just these lines here that represents the radii. Now, since OR and SR are radii, they are equal in length, which means that this triangle is going to be an isosceles triangle. That makes R1 X. Now we can use some angles in the triangle to solve for O1. O1 will be 180 minus 2x. Now angle P is going to be the angle at the circumference. And we know that the angle at the center is double the angle at the circumference. So angle P is going to be half of 180 minus 2x, which is 90 minus x. Next question, prove that S2 is equal to S1. Now to do that, I'm just going to clear up some space here, and I want to focus on the larger triangle, being this triangle right here. Now this triangle is also an isosceles triangle because they've told us that PS is equal to SR, which means that this entire angle here, R1 and R2, will also be 90 minus x. Now we can use some angles in a triangle to solve for S2. And if S2 is x, then we've proven that S1 is equal to S2. So let's do that. So we'll start by saying that S2 plus S1, which is x, plus 90 minus x plus 90 minus x equals 180, because that's a triangle. So S2 plus x plus 180 minus 2x equals 180. The 180 will cancel. S2 minus x equals 0. That means S2 is equal to x. And therefore, we've shown that S1 is equal to S2. Question 9.2 reads, in the diagram below, O is the center of the circle. A, B, C, and D lie on the circle. BOD is perpendicular to AC. At E, AO and BC are drawn. Prove that 2AO minus ED all squared is equal to BC squared minus AE squared. All right, so let's start with BC. So this triangle right here. And using the theorem of Pythagoras, we can say that BC squared is equal to EC squared plus, and it's going to be BE squared. But instead of BE squared, I'm going to instead write BD minus ED. So BD minus ED all squared. Now BD represents the diameter, okay? And we know that the diameter is double the radius, and the radius is OA or AO. So instead of writing BD, I can write 2AO. So BC squared is equal to EC squared plus 2AO minus ED all squared. So we've got our BC squared, we've got our bracket here, and all that's missing is AE. Now the next thing is that since OE is a line that is drawn from the center and AC represents a chord, and we are shown that it's perpendicular, it means that that chord is going to be bisected, meaning that AE is going to equal EC. So we can replace EC with AE. So our equation is now BC squared is equal to AE squared plus bracket 2AO minus ED all squared. Let's just rearrange this now. So BC squared minus AE squared is equal to bracket 2AO minus ED all squared. Finally, let's take a look at question 10.2. There's a whole lot of information here. Please pause the video and read through it. Let's take a look at the questions. Question 10.2.1 reads, prove that AC is perpendicular to DB. Now, we've been told that BC is the diameter of a small circle. So this line right here is the diameter. So since it's a diameter, it means that this angle right here is going to be 90 degrees. So since it's 90 degrees, it means that those lines are going to be perpendicular. Okay? Moving on, 10.2.2. Prove that AC is parallel to DP. Now to prove that AC is parallel to DP, we're going to first start with this tangent right here. That tangent makes an angle with these chords. So chord FB and chord DB. Those chords subtend two angles, angle C3 and angle P. So it means that angle C3 is going to equal angle P. So let's call this angle X. That's going to be angle X, and that right there is going to be angle X. And if we look closely, now we have the shape of an F, which tells us corresponding angles, which then implies that those lines are parallel. 10.2.3, prove that ABCD is a cyclic quadrilateral. To prove that ABCD is a cyclic quadrilateral, so this shape right here, what we'll do is we'll start with this tangent lines. AD and AB are tangents that originate from the same point, meaning that they are equal in length. That means that D1 is going to equal angle X. Next, we can use the converse of the angle in the same segment theorem to then prove that ABCD is a cyclic quadrilateral. Done. Next question, prove that CP is equal to CD. Now, to prove that CP is equal to CD, we need to show that C3 is equal to X. Now, how can we do that? Now, since we've shown that ABCD is a cyclic quadrilateral, we can do the following. Here's my chord, or segment, if you will. Means that this angle right here is going to equal this angle right here. So since that's X, C2 is also going to equal X. Right? So C2 will equal X as well. And since we've shown earlier that this line is parallel to this line, we can use alternate angles to then show that D3 is going to equal X as well. And now that we've shown that it's equal to X, it means that this triangle right here is isosceles, meaning that CD is equal to CP. And the last question, 10.2.5, prove that BR is parallel to AD. Now, BR is this line right here, and AD is this line right here. Now, how can we prove this? Let's take a look. So first thing we'll do is we'll make a note that since CB is my diameter, we know that this is going to be 90 degrees. But this angle right here is also going to be 90 degrees. Next, we know that since CB is a diameter and AB is a tangent, this angle right here is going to be 90 degrees. This B1 and B2 angle is going to be 90 degrees, right? And next point, since ABCD is a cyclic quad, opposite angles in a cyclic quad are supplementary, meaning they add up to 180. So it means that this angle right here must be 90 degrees as well. And now we've shown that this right here would make them parallel since you have co-interior angles. Okay? That's it. Thanks for watching. Hope you found it useful. I'll see you in the next one. Bye.